Good morning, my dear student. Today in our class, we are going to learn some more divisibility rule. In the previous class, we had learned the divisibility rules of 2 to 11. Today, we will learn the prime factorization of a given number by two methods, that is a factor tree method and a division method. So let us study in detail.
Let us observe some more divisibility rules. First rule is, if a number is divisible by another number, then it is divisible by each of the factors of that number. Consider a number 24. Here 24 is divisible by 8 and the factors of 8 are 1, 2, 4 and 8. So we can say if a number 24 is divisible by 8, then it is divisible by each of the factor also. Second rule is, if a number is divisible by two co-prime numbers, then it is divisible by their product also. For example, the number 80 is divisible by 4 and 5, and 4 and 5 are co-prime numbers. So 80 is also divisible by their product. It means 80 is divisible by 20 also. Similarly, 60 is divisible by 3 and 5, where 3 and 5 are co-prime numbers. So 60 is also divisible by their product, that is by 15. Third rule is, if two given numbers are divisible by a number, then their sum is also divisible by that number. For example, the numbers 16 and 20 are both divisible by 4. So the number 16 plus 20, which is equals to 36, is also divisible by 4. Fourth rule is, if two given numbers are divisible by a number, then their difference is also divisible by that number. For example, the numbers 35 and 20 are both divisible by 5. So their difference 35 minus 20, which is equals to 15, is also divisible by 5. Now let us study about the prime factorization. When a number is expressed as a product of prime numbers, it is called the prime factorization. For example, when we write 24 equals to 3 multiplied by 8, we say that 24 has been factorized. This is one of the factorization of 24. The other is, 24 we can write as 2 multiply 2 multiply 2 multiply 3. In this factorization, the only 2 and 3 are the prime number. Such a factorization of a number is called a prime factorization. We can find out the prime factorization of a given number by two methods. First one is factor tree and the second one is division method. Let us understand both the method one by one. First of all, let us find the prime factorization of the given number by using a factor tree method. Consider the number 90. Think of a factor, say 90 can be written as 10 multiplied by 9. Now think of a factor pair of 10. 10 can be written as 2 multiplied by 5. Now write the factor pair of the 9. 9 can be written as 3 multiplied by 3. So the prime factorization of 90 is equals to 2 multiply 5 multiply 3 multiplied by 3. Now find the prime factorization of 980 by division method. First of all, we will divide 980 by the first prime number, that is 2. After dividing 980 by 2, we get the number 490. And 490 divided by 2, we get 245. And 245 divided by 5, we get 49. 49 divided by 7, we get 7. And 7 divided by 7 is equals to 1. We divide the number 980 by 2, 5 and 7 in this order repeatedly so long as the quotient is divisible by that number. So the prime factorization of 980 is equals to 2 multiply by 2 multiply by 5 multiply by 7 and multiply by 7. Now let us solve the questions of exercise 3.5. Question number 3 is, which factors are not included in the prime factorization of a composite number? 1 and the number itself are not included in the prime factorization of a composite number. Fourth question is, write the greatest 4-digit number and express it in terms of its prime factors. The greatest 4-digit number is 9999. 9999 we can write as 9 multiplied by 1111. 9 we can write as 3 multiplied by 3. And 1111 we can write as 11 multiplied by 101. So the prime factorization of 9999 is equals to 3 multiplied 3 multiplied by 11 multiplied by 101. Question number 7 is, the product of 3 consecutive number is always divisible by 6. Verify this statement with the help of some examples. Let us take 3 consecutive numbers 2, 3 and 4. The product of 2, 3 and 4 is equals to 24, which is divisible by 6. Let us take 5, 6, 7, 3 consecutive numbers and their product is equals to 210, which is divisible by 6. Question number 8 is, the sum of 2 consecutive odd number is divisible by 4. Verify this statement with the help of some examples. Let us consider 3 and 5, 2 consecutive odd number and their sum is equals to 8, which is divisible by 4. 7 and 9 are also 2 consecutive odd number and their sum, which is equals to 16, is divisible by 4. 13 and 15 are also 2 consecutive odd number and the sum of 13 and 15, which is equals to 28, which is also divisible by 4. Question number 9 is, in which of the following expressions prime factorization has been done? First one is 24 equals to 2 multiply 3 multiply 4. Since 4 is a composite number, so prime factorization has not been done. B part is 56 equals to 7 multiply by 2 multiply by 2 and multiply by 2. Since all the factors are prime, hence the prime factorization has been done. Question number 10 is, determine if 25,110 is divisible by 45. 45 we can write as 5 multiplied by 9. And the factors of 5 are 1 and 5. And factors of 9 are 1, 3 and 9. Here 5 and 9 have only 1 as a common factor. So 5 and 9 are co-prime numbers. And the last digit of 25,110 is 0. So this number is divisible by 5. As 2 plus 5 plus 1 plus 1 plus 0, which is equals to 9. Since the sum of the digit of 25,110 is divisible by 9, so the number 25,110 is divisible by 9. Since the number is divisible by both 5 and 9, so we can say 25,110 is divisible by their product, which is 5 multiplied by 9 equals to 45.
Thank you for watching the video. I hope you understood the concept. Try to do the exercise 3.5 in your notebook yourself. See you soon in the next video. Till that time, take care.